All right, so review from test 5. First off, I already talked about number 2, the day of. 7 positive numbers and 6 negative numbers is going to be positive. It doesn't matter how many positive numbers you multiply together. It's always going to stay positive.
Wait, what?
Test 5. Are you looking at test 5?
Yeah, but when you multiply negative times positive, you multiply negative.
Yes, but notice how many negative numbers are we multiplying together? We don't just have one negative number, we have how many?
I read it backwards. Oh,
We have 6 of them. Okay, if you've got one negative number, it's negative. If you multiply 2 negative numbers together, they cancel out and become positive. 3, 2 of them cancel out, the other one makes it negative, and so on. If it's an odd number of negatives, the whole thing is negative because all of them except for 1 cancel each other out. Anytime we multiply something by a positive, it just stays positive. A negative times positive stays negative. So the number of positive numbers that we're multiplying together does not matter. All right. I think there was a similar question on test 6 that I think some guys made a mistake on. Okay, that was actually the only one that I had marked from test 5. You can ask me questions about it after I go over the ones that I want to review from test 6. Okay, so look at test 6 now. Yes?
I was going to ask if I fill in the correct answer on here right now.
Yeah, you want to start your corrections now? Go ahead. Okay, so looking at test 6 now. First off, question 2. 2, I'm surprised there were some issues with this. There was a lot of information that was correct, but not complete. Someone tell me what a rectangle is.
I said
And-
It's a type of square with 2 equal long sides and 2 equal short sides.
It's a type of, well, a square is not a type of square. A square is a type of,
Wrong.
I said a
Polygon.
oh, sorry, rectangle. Yeah, square is a type of rectangle, not the other way around. Yes?
I said a rectangle is a quadrilateral that has 2 sets of parallel sides.
No, because this also has 2 sets of parallel sides, and it's not a rectangle. This is a parallelogram. Rectangles are all parallelograms. It's true that rectangles are quadrilaterals that have 2 sets of parallel sides, but that's not a complete definition here.
A rectangle is a 4-sided polygon with all right angles.
4-sided polygon with all right angles. Okay, that works. You could say instead of 4-sided polygon, you could say quadrilateral. Just means 4-sided polygon. Instead of all right angles, you could say equiangular. All the angles are equal. There are a few different ways you could express this, but you have to get across that it's got 4 sides and that the angles are all equal to each other or that they're all right angles. That's what makes it a rectangle. Rectangle just means right-angled thing. All right. The next one I had marked was number 12. Okay, let's look at number 12. A lot of guys did things in sort of the wrong order here. We've got x over 1/2 equals 5. This is number 12. X, why am I doing this in the middle of the board? That is terrible board management. Number 12, x over 1/2 equals 5. So we're trying to get, anytime we have a problem like this where we're solving for the variable, we're trying to get that variable by itself. In this case, our variable is x. How can we get x by itself here?
Multiply.
Multiply. Why? What's happening to x right now?
It's being divided by 1/2.
It's being divided by 1/2. Remember, the fraction means divide by the thing on the bottom. Here on the bottom, we have 1/2. So to get x by itself, what do we have to do? Multiply by?
Yeah.
Multiply by 1/2. X divided by 1/2 times 1/2, those cancel out. Our multiplicative rule of equality says that we have to multiply all the terms on both sides of the equation by the same thing. So we got to multiply this 5 over here by 1/2 also. X is 5 over 1 times 1 over 2, or 5 over 2. A lot of guys divided by 1/2, or multiplied by 2. Things like that. Just ask yourself, what is currently happening to it? It's being divided by 1/2. If you think of it that way, it's clear that to undo that, we need to multiply by 1/2. Yes, we can have fractions within fractions. Dude, I heard you like fractions. So I put some fractions in a fraction so that you can work with fractions while you're working.
Fraction is the one thing I can do.
Hmm?
Is fraction the one that I do like?
No, I like fractions. What don't I like? What are the three things I don't like?
Subtraction.
Subtraction, division, and decimals, yes. Fractions I like. Fractions are nice and American. All right.
Hey, but if you multiply it 1/2 times 1/2, not just one, doesn't cancel out.
This is divide by 1/2. X is not being multiplied by a half here. It's being divided by 1/2.
Why?
Right? We can rewrite this first part as this. X divided by 1/2 equals 5. Then we could use our keep, change, flip rule of multiplying fractions. We could say X, keep, change, flip. There. We actually have to divide by 2 on this side. Or multiply by 1/2. X is not being divided by 1/2. All right, next up. Got 3 more. 16. 16, I think a lot of guys just didn't, we lost track of some negatives and some things went wrong there. So let's do 16 together. Someone please read aloud 16.
X, or negative x2, or squared,
Yep.
plus y, parentheses, x minus y, parentheses, minus m squared. If x equals -2, y equals 3, and m equals 4.
Yes. So, what do I do?
Oh yeah, fill in first. So, negative bracket, -2, or parentheses, yeah. Squared plus 3, parentheses, third parentheses right there. -2, parentheses, -3. Bracket, -4 squared.
Yes. I saw a number of guys make the mistake here of having these negatives cancel out. You can't do that. Why can I not have these negatives cancel each other out?
Because there has to go exponent first.
Right. Our order of operations tells us that first we have to square this -2. Canceling out negative signs is a form of multiplication because the negative sign means times -1. Before we can do the multiplication, though, we have to do the exponent. This is why I recommend that you write these things out fully before you start doing any simplification.
Yes.
So first we do the parentheses. So what happens first in this?
First, -5,
Where'd you get that from?
-2 minus 3.
Yeah, -2 minus 3 gives us -5. Okay. And what happens here when we square -2?
That's then 4.
Is -2 squared is 4.
But then the minus sign right there.
Right. Then there's this negative sign also. So first we square it. -2 squared gives us +4. -2 times -2. Multiply 2 negatives together, we get a positive. So it's -4 because there's also this negative sign here. We have to first square it and then make it negative. All right, we did the parentheses there, and then the exponent here, 4 squared is what? 16. All right, now we do multiplication. What are we going to get? We multiply 3 and -5.
-4 plus -15.
Yeah, -15.
-16.
-16. Okay, 4 plus 15 plus 16.
Practice that
Or -4 plus -15 plus -16, rather. Right, because this is just,
I see what I did.
How is it negative?
because it's -16.
Oh, yeah.
So we can say plus -16. What do we get when we add these three together? What's -4 plus -15? Yeah, we get what? -35, right. Because remember, when we're adding together numbers that have the same sign, we can just add them together And then the final thing has the same sign as they all did originally. So we do 4 plus 15, we get 19. 19 plus 16 gives us 35. We were adding 3 negative numbers together, the whole thing's negative. Negative 35. This though, this was the mistake that I saw, was canceling out those negative signs. Questions?
No, sir.
Okay, let's do number 18. That's the next one. I was a little surprised that 18, no wait, was it 18 or was it, did we skip 18? Yeah, it was 18. Yeah, there were a lot of issues with 18. I was kind of surprised by this. Okay, we've got this shape here. This is house type shape. All right, what do they ask us to find?
The area of the figure.
The area, okay. This is an irregular pentagon. It's got 5 sides. It's a polygon. 1, 2, 3, 4, 5 sides. It's an irregular pentagon. Do we have a formula for the area of an irregular pentagon?
Kind
What do you mean, kind of?
find the area of the triangle and find the area of the square.
Right, we're going to break it down into things that we know how to find the area of. So triangle and a rectangle. So we can say the area of the whole thing is the area of the triangle plus the area of the rectangle. Yes?
Yes.
Okay. In order to find this, we need to find the area of the triangle and the area of the rectangle. What's the area of the triangle? What's the formula for area of a triangle?
Base times height divided by 2.
Base times height over 2. What's the base of the triangle?
It is 15.
15, yes. This is a rectangle, remember. So 15 down here means 15 here also is the base of the triangle. What's the height of the triangle? 12 divided by 2. What are we going to get?
108. Oh, divided by 2 is.
It's like 6 times 15,
What?
so 90.
Right,
Oh, yeah.
right. So remember with this, we can also think of it as 1/2 times the base times the height. So the easy way to do this is you see 12 and 15. We know we have to divide the whole thing by 2. 12, we can easily divide that by 2. We get 6. So doing 6 times 15, I've already done the dividing by 2 there. 6 times 15 gives us 90. 6 times 15 is easier to do than 12 times 15. Especially since we have to divide by 2 anyway. Okay, so 90, what's the unit?
90.
90 what?
Feet squared.
Yes, 90 square feet. All right, now the area of the rectangle, formula for the area of a rectangle,
Length times width.
length times width. What's the length?
It is 11.
11, width is
15.
15.
Area is 165 feet squared.
Yeah, 165 square feet. Remember, I told you guys early in the year, maybe you remember this, an easy way to multiply numbers by 11. 11 is actually a kind of easy number to multiply by. What's 1 times 11?
11,
What's 2 times 11?
32,
What's 3 times 11?
33,
What's 4 times 11?
44,
What's 5 times 11?
55,
What's 6 times 11?
66,
What's 7 times 11? What's 8 times 11? 9 times 11? Okay, so if it's just a 1-digit number times 11, we just double that number. Easy. What if it's a 2-digit number? Well, if it's a 2-digit number, what we're going to do is there's this shortcut here. So if we're doing 11 times 15, our answer is going to be 3 digits. The first digit, we take the number that isn't 11, we split it up. 1 is going to be the first digit, 5 will be the last digit, and then to get the one in the middle, we just add those 2 together. 165. Why does that work? Because if we do 15 times 11, if we do it the long way, 1 times 5 is 5, 1 times 1 is 1. 1 times 5 is 5, 1 times 1 is 1. Oh look, the first digit is that first number there. The second is just the last one. And in the middle, we added them together. This is where brain matter ends up on the ceiling and the walls. Because your minds have been blown. Multiplying by 11 is easy.
495.
495. What's 61 times 11?
671.
671. Okay, easy. Okay, so once we get 165 square feet here, then what do we have to do?
Add
add them, so the area is 90 plus 165, or what? 255 what?
Feet squared.
Square feet, right, not dollars. Yes. Not ice cream. There. Okay. Questions about 18?
No.
Not entirely. Was 19. 19. Surface area, as always, causes issues.
Does.
Yes, it does. All last year caused issues. This year's continued to cause issues. Noticing a pattern here. All right, 19. Somebody please tell me the formula, the handy dandy formula I've given you guys for surface area, which
Surface
hopefully you all have engraved into your brains.
Surface area equals 2 times area of the base plus perimeter of the base times height.
Yes, always use this formula for surface area. It will not steer you wrong. It's easier than calculating the area of each side separately and adding them together. It's much harder to forget a side this way. Also, this will help you out if things are not, if you have like a weirdly shaped base. This will help you out. Okay, so we need area of the base, we need perimeter of the base, and we need the height of the thing. What kind of shape do we have in problem 19?
A cylinder.
A cylinder. So what shape is the base?
A circle.
A circle. How do we find the area of a circle?
Take the number that's already there and square it.
What?
Yeah.
Area of a circle. Come on, give me the formula. This should also be engraved into your brain.
Radius
Oh yeah, pi r squared.
to the second power.
Yes, pi r squared. All right. What about the perimeter of the base? The base is still what shape?
A circle.
A circle. How do we find the perimeter of a circle? Or what do we also? What's the other name for the perimeter of a circle? The circumference. How do we find the circumference of a circle? 2 pi r or pi times diameter. In general, 2 pi r is going to be a bit more useful for this kind of problem. Why? Because we're already working with radius when we're talking about area.
I'm supposed to divide by 2.
No, only if it's a semicircle. 2 pi r is the perimeter of the whole circle. And the base of this cylinder is a whole circle. All right, what's the height of this cylinder? 12 what?
12 centimeters.
12 centimeters. Remember, height doesn't mean top to bottom. Height means what distance is the height. We're talking about a solid. We're talking about a right solid. The height is the distance between the bases, right? So we look at this cylinder here in the picture. Even though it's on its side, it doesn't matter. The base is, how do we tell which side is a base of a right solid?
The rectangle. Whatever's not the
One at-
Right, if there's something that isn't a rectangle. In this case, oh look, there's a circle there. That's definitely not a rectangle. And there's another circle on the right side. The distance between those two is what's considered the height of our solid. So 12 here. All right, we've got the height. Let's find the area of the base and the perimeter of the base. What's the radius of this base?
6.
6 centimeters. So what's the area going to be? Pi r squared?
36.
36 what?
Pi.
36 pi
Centimeters squared.
square centimeters. Yes. Because we square 6, we get 36 times pi gives us 36 pi, and we're talking about square centimeters. The perimeter of the base is what?
6 pi.
No.
Negative.
2 pi r. So it's 2 times pi times what's the radius?
Radius is 6.
So what's the perimeter?
It's gonna be 12.
It's going to be what?
12 pi.
12 pi.
12 pi, yes, thank you. Sorry, I didn't hear the pi. 12 pi centimeters. All right, now we've got the area of the base, we've got the perimeter of the base, we've got the height, we can plug it in. So 2 times, what's the area of the base?
36. It's 70.
36,
72 pi.
yeah, 36 pi, plus the perimeter of the base is?
It's gonna be 140.
The perimeter of the base is 12 pi times 12. All right, 2 times 36 pi gives us 72 pi. Yes, pi is very important. What's 12 pi times 12? 144 pi. Okay, because these both have pi in them, we are allowed to add them together. We've got 72 pi's over here and 144 pi's over there. Delicious.
200.
And we end up with, yes, 216
Pi.
pi
Centimeters,
square centimeters, yes. 216 pi square centimeters, yes, yes. All right, any other questions from test 5 or 6? We have time for one or maybe two more to go over.
Oh.
I apologize that I was not able to be with you guys very much last week. That was.
Oh, that's okay.
Oh, by the way, in terms of homeworks, the homeworks from last week, which you were submitting online, if any of those are missing, just send them to me. I'll assume that it was because of technical things. I'll give you full credit. Yeah.
Wait, are any of them missing? Oh no, you still told me to show it to you on Monday. I was trying to show it to you Friday, but you said to show it to you 28th.
Oh,
You said to show it to you Monday.
yeah, and then.
I did it like.
Okay, so in just a minute, I'll take a look at it once I'm done sort of with the lecture portion here. But I do want to, unless there are one or two questions about 5 or 6, I do want to start 29 today.
Oh.
Can I give you my stuff till I'm done?
Just put them on my desk. If you're done for test corrections, yeah. And please have those by Friday to me. Quarter ends Friday. I will have office hours in here today. All right. Please open your textbooks to page 121, lesson 29, where we get to do more fun stuff with exponents.
No,
Yay, exponents! To be perfectly honest, the two things that will cause you the most trouble this year, besides surface area, which is sort of like a side thing. I mean, that's a geometry kind of topic. In terms of the algebra stuff, What's gonna- no,
Okay.
because there was a test
Yeah.
on Thursday, and then no school Friday, and then
Wait, we don't school Friday?
no, this past Friday there was no school.
Oh.
Wait, why don't we have a half day? It's like another quarter or the day off.
There's a half day the week after that on Friday, I think, for parent-teacher conferences.
Oh my god.
I don't know if I can do that.
I think I'll be good.
I actually really like conferences. It's really good to get a chance to talk with your parents, encourage them to go, even if they're not worried about your academics. It's good to touch base with the teachers. Anyway, all right. So, okay, lesson 29, exponents. Exponents and fractions are the two things that, unless you really get them down, are going to cause you issues all through the year. So let's talk a little bit about exponents. So we've got, when I say 3 squared, what does that mean?
9.
How'd you get to 9 from there?
It's
3 times 3.
Right, it means we take how many 3's? 2 of them and multiply them together. Okay, 3 and 3 is 9. What's 3 cubed?
3 times 3 times 3.
It's 3 times 3 times 3. Hold on, let me just move this down to 3 squared, 3 cubed. Okay, that's 3 times 3 is 9. 3 cubed is we take 3 3's and multiply them together, and we get what? 27. What's 3 to the 4th?
3 times 3 times 3.
Is 4 3's multiplied together. Okay, what will that give us? 81. All right. Easier way to do that than 27 times 3. We could do that. You get 3 times 3 is 9. 3 times 3 is 9. 9 squared. 81. Okay. What about 3 to the 1st? Is 3. It means take 1 3 and multiply it together, and
You get 1 3.
yeah, it's just 3. Okay. Let's look at the pattern here. So,
Wait, and if it's 3 to the 0.
wait.
it's
Shh,
one.
shh, 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 shh.
Sorry.
You're getting ahead of me. All right. I should have actually left more space up here. Okay. All right. So let's look at the pattern. As I go up from 3 to 9 to 27 to 81, what happens each step? Multiply by 3, because we're taking another 3 and we're multiplying it in there. So to go from 3 to 9, we multiply by 3. 9 times 3 gives us 27. 27 times 3 gives us 81. If we're thinking about it in the opposite direction, what happens? 81, 27, we're dividing by 3. So each time we go up, We're dividing by whatever our base is. Yes?
Yes.
Okay, so 3 to the 4th divided by 3, we get 3 to the 3rd, 27. Again, we go from 27 to 9, we divide by 3. To go from 9 to 3, again, we divide by 3. Gets 3 to the 1st. Now, to figure out 3 to the 0, the pattern should hold. So we're going to do what to go from 3 to the 1st to 3 to the 0?
No, divide by 0. Not 3.
We'll divide by 3 again, just like we've been doing. Each time this number goes down, we divide it by 3 again. So, what's 3 divided by 3? 1. Any number raised to the 0 power is 1. Any number raised to 0 is 1. You should know that. That's why I wrote it there. All right, any number raised to the 0 is 1. This is extremely convenient. Because if you've got a problem and you have x to the 0 in it, what's an easier way to write x to the 0? 1. It doesn't matter what number x represents. If we're raising it to the 0th power, it's going to give us 1. Okay, let's keep going. Let's say we want to go move this number down again. What if we want to get 3 to the, what number? What's the next integer below 0? Negative 1 3's and multiply them together. Okay, that way of thinking about it is not super helpful. So let's think of it in terms of dividing by 3 each time. So we take 1, we divide it by 3, and what do we get?
Oh, you get.
Negative
0.33.
I hate decimals. So how else can we say it besides 0.3 repeating?
Hold up.
1/3.
1/3.
All.
Right? We're dividing by 3 each time. So we divide by 3, 3 to the 0 is 1. To get to 3 to the negative 1, we divide by 3 again. We get 1/3. What if we keep going? What if I want 3 to the negative? See, I should have started much. Yes, 1/9. We divide by 3 again. What's 1/3 divided by 3? Is 1/9. 1/27th, 1/81st, etc. Negative exponent. Notice the pattern here. So we've got 1/3. 3 to the negative 2 would be 1/9. 3 to the negative 3 would be 1/27. 3 to the negative 4 would be 1/81. A negative exponent is the reciprocal of the positive exponent. So 3 to the first is 3. 3 to the negative 1 is the reciprocal of that, or just flip it over. 1/3. Because 3 is already 3/1. 3, if 3 squared is 9, what's 3 to the negative 2? If 3 to the 4th is 81, what's 3 to the negative 4th? 1/81. A negative exponent means we just take the reciprocal of the positive exponent. Or we could say it's 1 over the positive exponent. So on this page, they give you the definition of x to the negative n. So 1, I should write it the other way around. X to the negative n is the same as saying 1 over x to the n. Right? X to a negative power is the same as saying 1 over x to the positive of that power. Right? So in this case, 3 cubed, 27, or sorry, 3 to the negative 3, 1/27, is equal to 1/3 cubed. Those are equal to each other. A negative exponent means the reciprocal of the positive of that. One convenient thing that this lets us do is it means that we can take things with exponents and move them around between the top and the bottom of fractions. So watch this. Let's say we have, I'm I'm looking at example 29.1 on page 121, the bottom of the page there. Negative exponents, they're okay. I don't really like them, but I'll deal with them if I have to. But in general, if I can get rid of them, I will. So let's say we've got, this is example 29.1, we've got 3 to the negative 2. What's a simpler way to write that? Instead of 3 to the negative 2, I'd really rather have a positive exponent. How can I take this exponent and make it positive?
How do you take it as
1/3 squared.
Right, because remember, a negative exponent means the reciprocal of the positive exponent. So 3 to the negative 2, another way we could write that, which is usually, not always, but usually going to be more convenient, is to say 1/3 squared, or 1/9. You see how I did that? I said, I don't really like this negative exponent, so I'm going to move it to the bottom of the fraction, and then I just take this negative and make it positive. Yes?
I'm pretty sure, like, can't you do that because, like, when you flip it, it's like it becomes the reciprocal of it, like the negative becomes positive.
Yes. Yeah, so let's do another one. This is at the top of 122. Let's simplify 1/3 to the negative 3.
1 and 3. Oh, and then it'll become 3 for like because you go to the top.
Is the same as 3 cubed, or 3 cubed over 1. We can flip it around and make the exponent positive because we're taking the reciprocal, which means flip it. Move from top to bottom or bottom to top. Top to bottom, bottom to top. So we can move this 3 to the negative 3 from the bottom of the fraction to the top of the fraction. When we do so, the negative power to the negative third becomes to the third power. So 3 cubed is 27. Let's see what happens with a negative number. So let's say we've got negative 3 to the negative 2 power. Negative 3 raised to the negative 2 power.
negative?
How else can we write that?
-2. Sorry, like all the way around. 1/9. -3 to 0.
Right. So remember, we deal with exponents first. We can, instead of writing raised to the negative 2 power, we could make the 2 positive and flip the whole thing. So put it on the bottom of the fractions. Right now this is over 1. We flip it. Then when we do this, what happens when we square negative 3?
It becomes 9.
It becomes 9, right? We get 1/9 here. Don't be fooled by the fact that we've got these two negative signs. This negative sign here, this negative sign here, they don't cancel out because they're doing different sorts of things. This negative sign is a multiplication. This negative sign is an exponent. They're related, but they're not the same thing. Okay, remember our product rule for exponents. This is on the middle of page 122, you see there. The product rule for exponents means that if we've got a number raised to some power, and we're multiplying it by that same number raised to another power, we add the exponents together, right? X squared times x cubed gives us what? X to the fifth, right? Because x times 2, remember, means x times x. 2 x's multiplied together. That means this. X times x. And x cubed means x times x times x. 3 x's multiplied together. Now I've written those parentheses there to see that we've got x squared times x to the third. But remember, if it's all multiplication, the order doesn't matter. This is the same as just 5 x's multiplied together, or 5 x's multiplied together, you write as x to the fifth. Just an easier way of writing that. So what if we've got some negative exponents in these things? Let's look at example 4 on page 122. We've got this, x to the fourth, m squared, times x to the negative 2, m to the negative 5. What is that going to become?
X squared m instead of negative cube.
X squared, m to the negative 3. How'd you get x squared?
4 minus 2.
Right, because when we multiply x to the fourth and x to the negative 2, we add the exponents together. 4 plus negative 2 gives us 2, x squared. M squared times m to the fifth, 2 plus negative 5 gives us negative 3. What's another way we could write this? X squared times m to the negative 3. Anyone?
1 over m cubed, 1 over x to the negative squared.
Well, we don't want to make any more negative exponents. Well, let's keep x squared where it is. We could actually move the m to the negative 3, move it to the bottom, and make the exponent positive. Anytime we have a negative exponent, we can easily make it positive by just bringing it to the bottom of the fraction. Similarly, if we have a negative exponent on the bottom of a fraction, we can make it positive by bringing it to the top. Why? Because the negative exponent means reciprocal. And reciprocal means move things on the bottom to the top, and move things on the top to the bottom.
Now, so how can you do that with the x2 over
Sure. How does this work? Let me just make it a little more explicit. So we've got x squared m to the negative 3, which remember means x squared times m to the negative 3. We can rewrite this x squared, we can rewrite as x squared over 1. M to the negative 3, we're going to rewrite as 1 over m cubed, right? And then when we multiply these fractions together, I multiply across the top. 1 times x squared is just x squared. And I multiply across the bottom. 1 times m cubed is just m cubed.
And then on the other side, is it m negative 3?
On the other side.
Like the other side of the equation.
This one, where we started? Yeah, because we have m squared and m to the negative 5.
So, and then it's like, it would be m to the negative 3 at the bottom, and then x2 on top.
If right now everything's on top. When we start at
So
the
it would be m3 on the bottom, x2 on top.
yeah, just like this.
So, okay. So like, is that, like, we say that, since they both equal each other,
They don't equal each other.
on both sides.
Yeah. This is not an equation. This is just to simplify. We started with this, x to the fourth, m squared, x to the negative 2, m to the negative 5. And they ask you to simplify. They say write this in an easier form to deal with. An easier form to deal with than this is either x squared times m to the negative 3 or x squared over m to the third is usually even better than that. Okay. This rule with the exponents, it's actually, it works. It works also. I'm just going to erase these. This can help you see why any number to the 0 power equals 1. So let's say we have 4 squared times 4 to the negative 2. 4 squared times 4 to the negative 2. Now, let's try it by multiplying out these exponents. So what's 4 squared? 16. And what's 4 to the negative 2? 1 over 16. Remember 16, we write 16 over 1. Okay, what's 16 over 1 times 1 over 16? 1, because the 16 cancel out. Let's think of it a different way. 4 squared times 4 to the negative 2. The product rule of exponents means that if I have the same base and I'm multiplying them together, what do I do to the exponents? I add them together. 2 plus negative 2 gives me 4 to the 0 or 1. Look at that. It's like math makes sense or something.
Wait, Mr. O,
Yep.
when does the quarter end?
Friday's the last day of the quarter. All right, so let's see. We only have a few minutes. I'm going to assign lesson 29, but I'll check it on Thursday along with lesson 30. So tomorrow you'll have more time to work on things. But I won't check 29 tomorrow.
How many lessons in one night?
No. Okay, so for tonight, problems at 29, except, I just checked it. It's not. 3 and 4. But I'm going to check this on Thursday. But keep in mind, Thursday, lesson 30 will also be due. So tomorrow you'll have more time at the end until Thursday. Give you guys extra time to finish it?
But this is one of the- we have to figure it out.
Bro.
Yeah, I'm just pushing back the due date of 29 one day. That's all. All right, goodbye.
This is your extra house. Yeah.